Far beyond Neptune, at the frozen edge of our solar system, there exists a world that once held the title of the ninth planet. For generations, Pluto was introduced in classrooms as the final planet orbiting the Sun, a distant and mysterious object drifting through the darkness of deep space. It seemed permanent, a fixed part of our understanding of the cosmos. Then, in 2006, everything changed. Astronomers voted to redefine what qualifies as a planet, and Pluto no longer made the cut. Officially reclassified as a dwarf planet, Pluto suddenly became one of the most debated objects in astronomy. But instead of fading into scientific history, this small icy world became more fascinating than anyone had imagined. Pluto was first discovered in 1930 by a young astronomer named Clyde Tombaugh at Lowell Observatory in Arizona. Scientists had been searching for a mysterious object beyond Neptune, something they believed was affecting the orbits of other planets. After months of comparing photographs of the night sky, Tombaugh found a tiny moving point of light. That object would later be named Pluto, after the Roman god of the underworld. At the time, Pluto was celebrated as the newest member of the planetary family. For over 70 years, it remained the ninth planet, even though scientists knew very little about what it actually looked like or what kind of world it truly was. As telescopes improved, astronomers began to notice that Pluto was unlike any of the other planets. Its orbit was strange, stretched into a long oval shape instead of a near circle. At certain points in its journey around the Sun, Pluto actually moves closer to the Sun than Neptune. Its orbit is also tilted by about 17 degrees compared to the relatively flat plane followed by most planets. These unusual features made Pluto stand out, but the biggest surprise came in the 1990s, when astronomers discovered that Pluto was not alone. Beyond Neptune lies the Kuiper Belt, a massive region filled with icy objects left over from the formation of the solar system. Pluto turned out to be just one of many large frozen bodies in this distant region. This discovery forced scientists to ask an important question: if Pluto was a planet, then should all these other similar objects also be considered planets? In 2006, the International Astronomical Union introduced a new definition of a planet. According to the new rules, a planet must orbit the Sun, be massive enough to form a round shape, and clear its orbital neighborhood of other objects. Pluto met the first two conditions, but not the third. It shares its orbital region with countless icy bodies in the Kuiper Belt. Because of that, Pluto was reclassified as a dwarf planet. The decision created controversy around the world, but it also renewed public interest in this distant world. That same year, NASA launched one of the most ambitious planetary missions ever attempted, New Horizons. The spacecraft was designed to travel farther and faster than nearly any probe before it, carrying humanity's hopes of finally seeing Pluto up close. After launching from Earth in January 2006, New Horizons traveled at incredible speed, passing the Moon in less than a day and using Jupiter's gravity as a slingshot to gain even more momentum. Then it spent nearly 9 years crossing the dark outer solar system before finally reaching Pluto in July 2015. What New Horizons discovered completely changed our understanding of Pluto. Instead of a lifeless ball of ice, the spacecraft revealed a complex and surprisingly active world. Pluto's surface was filled with towering mountains made of water ice, vast frozen plains of nitrogen ice, and regions covered in deep red organic material. One of the most famous features was a giant heart-shaped region known as Sputnik Planitia, a smooth basin of nitrogen ice so young that it contains almost no impact craters. This suggested that Pluto is geologically active, with surface processes constantly reshaping the landscape. Scientists also discovered that Pluto has a thin but surprisingly extended atmosphere made mostly of nitrogen, with layers of blue haze stretching high above its surface. As Pluto moves closer or farther from the Sun during its long 248-year orbit, parts of its frozen surface can sublimate directly into gas, temporarily thickening its atmosphere. Evidence also suggests that Pluto may have cryovolcanoes, ice volcanoes that erupt mixtures of water, ammonia, or methane instead of molten rock. Even more surprisingly, some scientists believe Pluto may hide a subsurface ocean of liquid water beneath its icy crust, kept warm by internal heat. Pluto is not alone in its journey through space. It has 5 known moons, the largest of which is Charon. Charon is so large compared to Pluto that the two bodies orbit a point in space located between them, making them more like a binary system than a typical planet and moon. The relationship between Pluto and Charon may help explain why Pluto remains geologically active despite its small size and extreme distance from the Sun. Today, Pluto remains one of the most mysterious objects in our solar system. It may no longer hold the title of planet, but what New Horizons revealed proved that labels do not define a world's importance. Pluto is not just a frozen rock at the edge of the solar system. It is a dynamic, evolving world filled with mountains, glaciers, atmospheric haze, and secrets still waiting to be uncovered. In losing its status as a planet, Pluto may have gained something far greater, the attention of an entire generation determined to understand what lies in the darkness beyond Neptune. As scientists continued studying the data sent back by New Horizons, Pluto became even more astonishing. One of the biggest surprises was the complete lack of impact craters across large areas of its surface. In most parts of the solar system, old worlds are covered in scars from billions of years of collisions with asteroids and comets. Pluto, however, seemed to be constantly renewing itself. Regions like Sputnik Planitia appeared geologically young, possibly no more than a few million years old, which is incredibly recent on a cosmic timescale. This suggested that powerful forces beneath Pluto's frozen crust were still shaping the surface, pushing fresh ice upward and erasing ancient damage. Researchers soon realized that Pluto's frozen plains were not made of ordinary water ice alone. At Pluto's extreme temperatures, water ice becomes as hard as rock, forming the mountains and cliffs across the landscape. But the smoother plains are made mostly of nitrogen ice, mixed with methane and carbon monoxide. Under Pluto's weak gravity and freezing conditions, these ices behave almost like glaciers on Earth, slowly flowing across the surface over millions of years. Images from New Horizons showed clear evidence of frozen rivers, moving ice sheets, and giant polygon-shaped patterns created by convection, where warmer material rises from below while colder material sinks. This meant Pluto was not geologically dead, it was active, moving, and changing. Another major discovery came from Pluto's atmosphere. Before New Horizons arrived, scientists knew Pluto had a thin atmosphere, but they had no idea how beautiful or complex it would be. When the spacecraft looked back toward Pluto with the Sun behind it, it captured stunning images of blue atmospheric haze surrounding the dwarf planet. Multiple layers of mist extended more than 100 miles above the surface. Scientists believe sunlight interacts with methane in Pluto's atmosphere, breaking the molecules apart and forming complex organic particles called tholins. These particles slowly fall back to the surface, giving many parts of Pluto their reddish-brown color. It is possible that over millions of years, this process has painted much of Pluto with a thin layer of organic material. One of Pluto's strangest regions is an enormous dark red area stretching across part of its equator. Informally nicknamed Cthulhu Macula, this region is one of the oldest surfaces ever observed on Pluto. Unlike the younger icy plains, this area is heavily cratered and appears to have remained unchanged for billions of years. Its deep red color likely comes from tholins created by radiation from the Sun interacting with methane and nitrogen. In some ways, this ancient landscape preserves a record of Pluto's earliest history, almost like a fossil from the birth of the solar system. Then there is Charon, Pluto's largest moon, which turned out to be just as fascinating. Charon is about half the size of Pluto, making it one of the largest moon-to-parent body ratios in the solar system. Because of this, Pluto and Charon do not behave like a normal planet and moon. Instead, they orbit a shared center of gravity in space, locked together in a gravitational dance. Charon always shows the same face to Pluto, and Pluto always shows the same face to Charon. If you stood on Pluto's surface facing Charon, the moon would never rise or set, it would remain fixed in the sky forever. New Horizons also revealed that Charon has its own unique features, including massive canyons stretching for hundreds of miles and a mysterious dark red polar region. Scientists believe this red cap may form when gases escaping Pluto's atmosphere are captured by Charon's gravity, frozen at its poles, and chemically altered by solar radiation. This means that even though Pluto and Charon are separate worlds, they are constantly influencing each other in ways we are only beginning to understand. Perhaps the most exciting possibility of all is what lies beneath Pluto's frozen surface. Based on the shape of Sputnik Planitia and the way Pluto's crust appears to shift over time, many scientists believe a liquid ocean may exist deep underground. This hidden ocean could be made of water mixed with salts or ammonia, preventing it from freezing solid despite the extreme cold. If true, Pluto would join a growing list of icy worlds in the solar system that may contain subsurface oceans, including Europa, Enceladus, and Titan. These hidden oceans are especially important because liquid water is considered one of the key ingredients for life. Even after its historic flyby in 2015, New Horizons did not stop. It continued deeper into the Kuiper Belt, exploring regions no spacecraft had ever visited before. Every piece of data it sends back helps scientists understand not only Pluto, but the early history of our entire solar system. Pluto may have lost its title as the ninth planet, but in many ways, it has become something even more valuable, a gateway to understanding the ancient outer solar system and the countless frozen worlds waiting in the darkness beyond Neptune. As researchers analyzed more of Pluto's data, one question continued to dominate scientific discussions: where does Pluto's internal heat come from? This small world should have cooled down billions of years ago. Compared to planets like Earth or even moons like Europa, Pluto is tiny. It does not experience the same intense gravitational stretching caused by a nearby giant planet, which is usually what keeps icy worlds geologically active. And yet, Pluto clearly shows signs of internal energy. Its glaciers move. Its surface reshapes itself. Possible cryovolcanoes rise from its crust. Something deep inside Pluto is still alive. One theory points to radioactive elements trapped within Pluto's rocky core. As these elements slowly decay over billions of years, they release heat, possibly enough to maintain pockets of liquid water beneath the surface. Another theory suggests that Pluto's relationship with Charon may be responsible. Billions of years ago, scientists believe Pluto may have collided with another large object in the outer solar system. Instead of completely merging or breaking apart, the collision may have created Charon and injected enormous amounts of energy into both bodies. That ancient impact could have reshaped Pluto forever, leaving behind internal heat that still influences its structure today. Evidence of this violent past may be written directly onto Pluto's surface. Some researchers believe the famous heart-shaped region, Sputnik Planitia, may actually be the scar of an ancient collision. The basin is enormous, stretching nearly 1,000 miles across. It appears to be filled with layers of nitrogen ice that have slowly accumulated over time. But the location of this basin is unusual. It sits almost directly opposite Charon. Some scientists believe the immense weight of Sputnik Planitia may have caused Pluto's entire outer shell to slowly rotate, repositioning the basin into a more stable alignment with Charon's gravity. If true, Pluto may have literally reoriented itself over millions of years. The more we study Pluto, the more it challenges what we thought we knew about planetary science. For a long time, scientists assumed that small icy bodies at the edge of the solar system were frozen, inactive, and geologically dead. Pluto shattered that assumption. Instead of silence, we found movement. Instead of emptiness, we found atmosphere. Instead of a simple frozen rock, we found a world with layers, seasons, chemistry, and possibly even liquid oceans hidden below the surface. Pluto forced astronomers to rethink what small worlds are capable of becoming. Pluto also experiences seasons unlike anything on Earth. Because of its extreme tilt and its long 248-year orbit around the Sun, different parts of Pluto can spend decades or even centuries in darkness. As Pluto moves closer to the Sun, surface ice can vaporize and form a thicker atmosphere. As it moves farther away, that atmosphere can freeze and collapse back onto the surface. Entire regions may change dramatically over the course of a single Plutonian year. What New Horizons captured in 2015 was only one moment in a constantly evolving cycle that humans may never fully witness in real time. Even now, years after the flyby, scientists are still discovering new details hidden in the data. Every image, every atmospheric measurement, every surface scan continues to reveal new questions. Could Pluto's underground ocean still exist today? Could cryovolcanoes still erupt beneath its icy crust? Could the chemistry on its surface tell us something about how organic molecules spread through the outer solar system? These questions remain unanswered, but Pluto has already proven one thing: distant worlds can be far more complex than we ever imagined. For now, no new mission to Pluto has been officially approved. New Horizons remains the only spacecraft ever to visit this distant world. It crossed nearly 3 billion miles of space, spent only a few hours gathering close-up data, and then continued into the darkness beyond. Yet in that brief encounter, it completely transformed our understanding of one of the most famous objects in our solar system. Pluto may no longer be called a planet by official definition, but titles mean very little in space. What matters is what a world can teach us. And Pluto, once dismissed as a frozen leftover at the edge of the sun's influence, turned out to be one of the most extraordinary worlds humanity has ever seen. In the darkness beyond Neptune, far from the warmth of the sun, Pluto continues its slow journey through space, silent, mysterious, and still full of secrets waiting for the day we return. And perhaps that is what makes Pluto so unforgettable. It was once introduced to us as the smallest and most distant planet, a quiet object sitting at the edge of the known solar system. Then science changed its label, and for a moment, it seemed as if Pluto had lost its importance. But what happened next proved something powerful. Our understanding of the universe does not become smaller when definitions change. It becomes deeper. Pluto was never just a name in a textbook. It was a world waiting to be discovered, and when humanity finally reached it, Pluto revealed a level of complexity that no one expected. Today, Pluto continues its endless journey nearly 4 billion miles from the Sun, moving through the icy frontier of the Kuiper Belt. One orbit around the Sun takes 248 Earth years, meaning Pluto has not completed a full orbit since the day it was discovered in 1930. Entire generations will come and go before Pluto returns to the same point in space. Seasons there last for decades. Sunlight is so weak that daytime feels like twilight on Earth. Temperatures drop to nearly -230 degrees Celsius. And yet, against all odds, this frozen world remains active, dynamic, and full of energy. Somewhere beneath its surface, an ocean may still exist, hidden under layers of ice and frozen nitrogen. Across its plains, glaciers may still be moving so slowly that their motion can only be measured over millions of years. Thin layers of blue haze may still be rising into the darkness above its surface. And on Charon, its giant companion moon, red polar ice may still be collecting from particles that escaped Pluto long ago. Even in the coldest and most distant corners of our solar system, nature refuses to stand still. New Horizons may have completed its flyby, but its legacy is only beginning. The mission did more than photograph Pluto, it changed the way we think about the outer solar system. It showed us that the distant worlds beyond Neptune are not lifeless leftovers from the birth of the Sun. They are active, evolving worlds with histories, chemistry, and mysteries of their own. Pluto became the first chapter in a much larger story, one that stretches deep into the unexplored darkness of the Kuiper Belt. And perhaps one day, another spacecraft will return. A mission designed not just to fly past Pluto, but to orbit it. To map every mountain. To study every glacier. To search for signs of hidden oceans beneath its frozen shell. To understand how such a small world managed to remain alive for billions of years. That mission may not happen tomorrow, or even in the next decade. But Pluto has already earned humanity's curiosity, and curiosity has a way of coming back. Until that day, Pluto remains out there, small, silent, and impossibly far away. No longer the ninth planet, but something far more interesting. A reminder that the universe does not care about our labels. It only waits for us to look closer. And when we finally did, Pluto changed everything.